So what do we have here? You see two lines, and why are there two lines? Because there's already a third line over there that's on there too. But had to go to a wrecking yard at a shop here. They made a little mistake, and it was a young guy's first time, and so he did something he shouldn't have, and he didn't know. He knows now. AC can be a little tricky on some of these lines when you just don't quite have the feeling for it. Can you see the mistake in this picture? Okay, look carefully right down here. Let's zoom in on it. Right there. So that's what happened. And more of you senior techs, the guys with experience, know what happened and exactly how it happened. So what happens, and this often happens with a lot of fittings, somebody may put it in and they don't put it in all the way, and it's slightly tilted, so it's not straight, and it did not go down inside the bore. It was actually sitting part way, as you can see from the marks right here. You see this mark? It's not a straight mark, it's round. You see this mark? It's round in this direction. So it was very difficult to see and difficult to judge by feeling for him with less experience. And the way it's all attached inside there and rigid, everything was fixed, it wasn't pliable. That might have been one mistake, that things weren't all left loose. So they were not attached. So for those of you who are experienced, know that when things are not attached and you don't know about it and it's overlapping, that you can see right there, then a guy will commonly use the nut on top and then just try to air wrench it down or tighten it down to force it into place. And unfortunately, as we learned in physics class back in grammar school, matter, two pieces of matter, two objects, cannot take up the same space, at least in the physics in the world that we live in. Unless you get down to the gluons and Higgs boson and those other kind of things. In a black hole, maybe you could do that. But other than that, yeah, two things in one space don't work. And so that was the result. And so we're back on this vehicle from last week, or was it last week or earlier this week, that I found the leak on the condenser. And if I remember correctly, I think it was up in this corner, if you look back in the videos from a couple days ago, or it was down in this corner down here with the UV dye. And this was a vehicle that I did back in 2019, and I put UV trace dye in it, so sometime in the future, if it ever leaked like this, it was really easy to find. So all this went back, and he said it was easier to replace the condenser. The condenser is by the other, behind the other heat exchanger right there in front, sandwiched between the radiator and the first heat exchanger. The condenser is the second heat exchanger in the middle of the three. He said it was easier to replace that than it was to replace the receiver dryer down there. So as you can see, it has a hard shut off solenoid valve, just like on a freezer unit, and I could feel it's energized. It's hot right now, and it should be when you're performing your recovery or your recharge. Otherwise you'll leave air in the back half of the system, or you'll leave refrigerant in the back half of the system. And that's why these vehicles are good money makers for me, because guys don't read RTFM. So these cars go to some place like a Jiffy Lube or a Quickie Lube, or something Super Tune, something, or just somebody, and they throw it on the machine and they recover out the refrigerant and they recharge the refrigerant, and if it's a cool enough day, it works. But then the customer drives somewhere where it's really hot and it stops working. Why? That is the question, why? I am not going to tell you. I just gave you some of the information, and with the information I gave you about the story, you can tell me why, when one of these vehicles come in to a shop, get recharged, they do a recovery, and they do a recharge with the full quantity of refrigerant that is required, which is, I think, 1,000 something. Where are we at? 1,080 grams. With 1,080 grams, and if it was a cool day, the vehicle works fine. Customer goes out, and when they go somewhere hot, it stops working and cutting out. And should I give you some more information? Let me see. In a severe case, I think if I give you this piece of information, too many guys will get it because it's just telling too much. Okay, so it'll go out on a hot day, not work. It comes back to the shop, and the guy might put his gauges there, and like it is right now, I'm here in San Francisco, it's 62 degrees outside. So this car comes back to me after going across the bay on the weekend when it was 85 degrees, and the customer says it wasn't working. The vehicle comes back, and it comes back to me as a shop guy, and I don't know too much. I just hook up some gauges, and let's say I look at some pressures, and I see 180 on the low side, and I see 35 on, or 180 on the high side, and maybe 31 or 35 on the low side, and it's coming out 45 degrees out the dash, and I say it's good, there's nothing wrong with it. And maybe the boss says, well, just to make sure, recover it and recharge it again. So you throw it on the big dumb machine, you throw this on the big dumb machine, you hit the recovery, you let it go through its paces, and the machine does the recovery. It does a little check for vacuum to make sure that there's no refrigerant left in the system, that doesn't go up no more. So now you put it on the vacuum, put on vacuum for 15 minutes or an hour, whatever you guys do, and you weigh out the scale, 1,080 grams. It puts 1,080 grams in it, and it's coming out 42, 45 degrees again. And the customer takes it, and you're all happy because you did everything right. And he comes back next weekend saying, hey, I went out across the bay on the weekend, it was 80 degrees, and my AC stopped working. Why? Leave the comment of why this particular vehicle has so many problems with shops right after a recharge. And if it was recharged on a mild to cool day, but then the customer takes it somewhere hot and the AC stops working, but yet they performed all the procedures that the machine tells you and it was properly charged, why does it stop working? All right. Oh, should I divide this into 2 videos? No, it's not the 15-minute mark yet. Something about, I hear about YouTube in their algorithm and 15 minutes. So let's go. Now I get my hands dirty. So my whole purpose was this nitrogen charge, nitrogen pressure testing. So all this work was done, and things were replaced, and we have we have 2 seals here. Now there's not just one seal, there's 2 seals. How many times do you think guys change this seal, if they change them at all? You see the little rubber O-ring right there, but look at this. There's another seal right there. Okay? Change both seals, but a guy will go, oh man, they said they didn't have that seal, so I'll just do one. Okay, you just go ahead and do that one. Sometimes it works, sometimes it doesn't. But when it doesn't, don't complain, don't whine and cry. Go look in the mirror, and there lies your problem. All right, so I have it on the nitrogen. I've had this on the vacuum pump because I want to clean out any air. Remember, when I did the recovery on this before, I backfilled it and purged it with nitrogen. So when the technician takes it apart, instead of being under a vacuum and taking in moist air from outside, it's under a slight positive pressure with dry nitrogen. That was done. He replaced the parts. I'm performing a vacuum in case there was any air, and there's always a little bit. When you take it apart, some air with moisture gets inside. So I'm performing a vacuum before I add nitrogen, because I don't want to pressurize that moisture of any air that got into the system, into the oil or anything like that. I want to remove it first and then pressurize. So let's start this back up. It's timed out to save the battery. I'm going to push it through the high side and then later take it out the low side. I'm going to perform a sweep. So I close the high side. High side is closed. Close the vacuum. Got it. And now I'm going to, this is already open. Yep, that's open. and you can see it going up a little bit, but I'm not worried about that. Now I'm opening up the pressure, and you can see it's at 19 psi. Okay, more than enough, way more than enough. Actually, I only want it to go to like 2-3 psi, like that. 20 is more than enough, because I'm not, well, I am going to do that. I'm not doing the vacuum purge, triple vacuum purge. I'm doing the pressure test first. I'm going to do that. So let's keep going. We're going to do a pressure test. Let me crank it up. Let's get some pressure going in here. And I'm going to do a pressure decay test. I want to go up a little more. That's too much. Okay. Let's bleed a little off. See, now this is where the expansion valve, the spring pressure and the blocking off of the expansion valve will not let any more pressure go past than that difference right there. It's just barely bleeding by. So I'm going to put a little bit over into the low side. Let it come back up. Adjust my regulator, and this time not too much. Okay, now this is what you would normally do. You would just let this sit. The proper way to do this, let this sit for 5 or 10 minutes before you isolate the pressure, because you want the hoses to they're slowly expanding, and O-rings are moving, and anything that's going to move under pressure is going to move in the first few minutes. Different materials react differently, and different size systems. So you would let this sit for 5 minutes, and then you would turn off the nitrogen, and then you would put it into tightness test. There, it's in tightness test. And you would make sure, because it might move a few tenths within the first few minutes, but I'm not waiting that first few minutes because I'm doing a video. And you see there's no immediate big leak, and then you would hit tightness test right here. Okay, so now, sorry guys. And then you would hit enter, like it says up here, enter, to start tightness test. Boom. So now the timer right here in seconds and minutes will count down. And see this last tenth of an inch? This is pound PSI. And then this is tenths of a PSI. 8 right there. And then this is how much you drop. You see 0.0, and then if it drops, it'll go negative 0.1. You see how that one went negative 0.1? Now if this one drops negative 0.1, we'll see a 0. There it goes. It's almost going. Let's see if we could drop one. There it goes, like that, 0.1, which is nothing really. And it'll keep doing that. Now with an analog set of gauges, you could never see really small stuff, but I'm accounting this as not being a leak. It's just me being impatient, not waiting 5 or 10 minutes for it to stabilize out before I crank off the pressure and turn on the test. Don't be in a rush. So I'll do this for a few minutes, and I'll come back instead of us watching paint dry or grass grow, and let's see what this is after 5 minutes. I'm going to go for 5 minutes because I see it's not no big drop. It's not drastic or anything like that. So I'm not going to show you anything because everything is new on here. I'll come back in 5 minutes. And as long as this is less than a PSI, I should be good to go.